Processor examples. In a previous topic, we discussed what is interrupt, what happens inside the microprocessor when interrupt occurs. The same analysis we are going to do with the ARM processor, Motorola 68000 and Pentium, Intel Pentium. So now here in this lecture, we will see the ARM processor, interrupt structure, ARM interrupt structure. Now ARM is a advanced RISC machine. Total in this processor, total 5 sources of exceptions are there. For external interrupts, request lines are there. One is IRQ and second one is a FIQ, and one software interrupt, and 2 exceptions caused by the abnormal condition encountered during the program execution, like if any errors occurs in the data reading, writing, and uh, prefetching instructions, that time these 2 exceptions will occur. Now here if we see the priority levels, total 6 types of priority levels are there. First, reset is having the highest priority. When we press the reset, it brings the system back to the starting condition. Now data abort, when any data errors are occurred, then that type of this exception rises. And FIQ, which is caused by the IO devices, fast interrupt request. Similarly, IRQ is also caused by the IO interrupt request. So there are 2 external IO requests are there. Prefetch abort. Now here ARM is used supporting the pipeline mechanism. So when one instruction is being executed, before only the second instruction fetching takes place. So that time, if any type of errors occurs, prefetching errors occurs, then this exception rises. Now undefined instruction. Now every processor is having its instruction set. If in one instruction which is not meant belong to that instruction set, if we are using that type of instruction, then the undefined instruction exception rises. This is having the lowest priority. Now if we see here this is the register structure of ARM processor. Now 0 to 31 means a total 32-bit length of registers are available, and 0 to 14 means a total 15 registers are general purpose register, and R15 is nothing but a program counter register, and along with this one more status register, CPSR. CPSR means current process status register. Now in this, if we see 0 to 4, first 4 bits, and 0 to 4 means what? Total 5 bits are indicating the processor mode. So already in the interrupts, I have explained that we can operate processor in 2 modes. One is user mode and another one is a supervisor mode. But this ARM processor, we can operate in total 6 different modes. One is a supervisor mode and the remaining 5 are the privileged modes. So in which mode we are operating this system? By using these bits, we can analyze. Now next, 6th and 7th one are for the interrupt disable bit. Now already 2 types of interrupts are there, external interrupts. One is a IRQ and FIQ. While already executing that ISR, again the same system should not generate the interrupt. For that purpose, we can disable the interrupts by using these bits. Now the remaining all bits are unused bits, and if we see the last 4 bits are the conditional flags, which indicates the processor condition. After executing every instruction, this CPSR will be updated, and it indicates the what is the condition, what is the status of the processor after executing the particular instruction. N is a negative, means what? Result is negative or not, it will indicate. 0 means if the result is 0 or not, it will say. And carry means if they are doing the addition or subtraction, if any carry is generated or not. By seeing this flag, we can analyze. And overflow, if we are doing any process, if the result is crossing the length of the process, then this flag occurs. Now here, now in this, we are analyzing the interrupt structure. So that's why we need only these bits, 0 to 7 bits. Once again, we try to analyze those bits. Now already we have discussed that 0 to 4 means it will indicate the mode, in which mode we are operating. Total 6 modes are there. So in which mode we are operating. Generally, it is in the user mode. Whenever the exception occurs, then it will switch to the 5 different modes. If this is one, then it will be one mode. If this bit is one, then it is in the second mode. Like that, 5 bits are indicating the 5 different modes. And also here you can see I is IRQ bit, F is FIQ bit. Now, if we want to disable the interrupt while executing the ISR, then by keeping this bit is equal to 1, we can disable. In the interrupts, when I said that IE is equal to, when keep is equal to 1, IE is equal to 1, then we are enabling the interrupt. I said IA is equal to 0 means disabling ISR. Now, in this ARM processor, whenever it is executing the ISR, that time if I wanted to disable the particular interrupt, then we have to make this bits is equal to 1. By making this bits 1, we can disable the particular interrupt. Now, these are the different modes. This is the user mode, FIQ mode, IRQ mode, supervisor mode, abort, and undefined. These 5 modes are there. Now, what type of exception if it will switch to these 5 modes whenever the exception, different exceptions occurs. Now, for what type of exception, which mode it will shift, we will see here. Now, if the reset is happened, then it will switch to the supervisor mode. If undefined instruction is given in the program, then it will switch to the undefined. If the software instruction is given, then being executed, that time it will switch to the supervisor mode. If abort during uh, prefetch, abort during data, if these type of errors are occurred, prefetch error are occurred, data error are occurred, then at time it will switch to the abort mode. And here reserved, so no, nothing is there. Now, IRQ and FIQ both are the external interrupts. When IRQ interrupt is generated by the IO device, then it will switch to the IRQ mode. FIQ is generated by the IO device, then it will switch to the FIQ mode. Now, whenever the different exception, now these exceptions are raised, then it processor is supposed to execute the exception service routine. Now, to run that exception service routine, processor should know the starting address. For that, now if this reset is occurred, then processor will go to this address. Now here the branch instruction is mentioned. By using that branch instruction, it will go to the starting address of the exception service routine of this reset. Like similarly, for all this up to ISR, this is the, now in this location, it branch instruction will be there. That branch instruction will take the processor to the starting address of the ISR. Now coming to the FIQ, now whatever the address is mentioned here, this is itself the starting address of the FIQ. FIQ is nothing but a fast interrupt request. Means what, execution latency should be very less. After receiving the interrupt, how much time it is taking to execute the ISR, that is called the latency time. That should be less. That's why here. Now this is the starting address. From this address onwards, till the return instruction, the program is, the ISR program is here. It will execute all those instruction to execute the ISR of FIQ. Now we will see the in different mode, what are the different registers we will see. Now here if you see user mode, R0 to R14 is the general purpose register, and R15 is common. If you see in all the modes, R15 is common. This is the program counter which holds the address of the next executable instruction. Now R0 to, if we see the remaining all privileged modes, R0 to R7 is also common in all the modes. But coming to the last 4 modes, now R18 to R12 is similar to the user mode. Similar to the user mode means what, last 0 to 12 registers are similar to the user mode. But coming to the 13 and 14, now this hyphen, that specific mode is mentioned, means those are called the bank register, and those bank registers are used for specifically for that mode only. Now here 13, 14 are, now if you see in all the modes, 13, 14 registers are reserved for that particular particular mode. Now coming to the FIQ, R8 to R12 are also reserved. Banking registers are there for the FIQ. Means what is the mean? Now this I will explain later. Now let me explain now what happens if now this is a CPSR. Along with this register, one CPSR register is there in the user mode. Now, coming to the other modes, along with the CPSR, it is having the SPSR register. Now, when the interrupt occurs, what happens inside the microprocessor? Now, already we know that interrupt occurs, then processor will store the program counter value and status register value onto the stack we have studied in the interrupt concept. Now coming to the ARM processor, now program counter value is nothing but a R15 value will be stored onto the R14 of that particular mode. Now for example, if IO device is sending the FIQ interrupt, then processor will switch to the FIQ mode. Then this R15 value is placed onto stored onto the R14 FIQ register, and R15 will be replaced. The R15 will store the ISR starting address of the ISR of FIQ, and it will execute the ISR program. Now, and after that, CPSR is a status register content will be stored onto the SPSR. SPSR is nothing but a saved process status register. Now, whichever the user mode is switching to whichever the mode, in that mode, now we can see that specific SPSR register is there. So CPSR value is stored onto the SPSR. Now instead of storing onto the stack, it is storing onto the register only. To store this content, PC value and the status register value to store, there are specific registers are mentioned within the microprocessor. Thereby what? It is reducing the latency time. So going to the memory and storing there, it will take some time. So latency time is reduced by storing the content onto the within the processor in the specific registers. Now coming to the R13. R13 is a stack pointer. R13 is used for the stack pointer. Now these are the registers in the user mode and different modes. Now this is happens when the interrupt is occurred. Now after completing the execution, again when it is coming back, CPSR value is stored onto the SPSR value is stored onto the CPSR, and R14 value is again stored onto the R15, and again the main program will be resumed where it has stopped. This is what when the interrupt occurs, and after coming back again what is happening here. Now then what is this R13? R13 is a stack pointer. Then why we are using this stack? If we are not saving this content onto the stack, then when we are using the stack means, now here if you see from the user mode, the processor is executing one program. When FIQ interrupt is occurred, then it will store the R15 value onto the R14, and it will store the CPSR value onto the SPSR, and it will execute the in R15 starting address of the FIQ ISR value will be stored, and it will execute the program. Now in between, if the reset is happened, then it will jump to the supervisor mode. That time already this R15 value supposed to be stored onto the R14 of the SVC, and again this CPSR value will be stored onto here, and it will take the starting address of the exception service routine, and it will execute that. Means what? Nesting already we have seen that if the processor is executing one ISR, in between any interrupt occurs, and it will check the priority, and depending upon the priority, it will execute the second ISR. In between one ISR, it is executing one ISR is called the nesting. Now here, if the request comes from the different modes, then there is no need to store the content onto the stack. Again, for that, again, the specific registers are there. But now if the processor is executing the main program, that time FIQ is occurred. In between, when it is executing the ISR of FIQ, in between again the same FIQ is occurred. Then already this R14 is filled with the starting of first PC value, first PC value. Then again the second time if the FIQ interrupt is occurred, then it can't store the already present ISR PC value onto the R14. It is replacing. It is replacing means what? Again, it is going to lose the address of the main program where it has to resume. That's why what? When the same in the nesting, if the same device is sending the interrupt request, that time it will store the PC value and CPSR value onto the stack by using the R13 register. 13 is what? Stack pointer. Always it indicates the top of the stack. Now this is what happens inside the ARM processor when the interrupt occurs. So we will study the Motorola and Intel in the next lecture.